Hey guys, it's Mrs. McDaniel. I am here to teach lesson 7.2. You can use this to refresh your memory on how to do it, or if you miss class, this would be a great thing to watch. So, we're looking at performing operations with radical signs. So, we're talking cube roots, square roots, fourth roots, all those things. We're going to add and subtract, and also we'll do some multiplication. So we're going to start with adding and subtracting. We're going to roll through these pretty quickly. If you look at the two rules at the top, you're going to simplify, and that means you cannot add or subtract radicals if they're different. That means the radicand, and the index need to be the same. So this right here is really important. And then you are going to add and subtract the coefficients. And then you do not change the radical. So let's look at this first one. The radical is kind of like an x. So if you think of this as like a negative 5x minus 3x, it's very similar to what we have there. So like if this is kind of the same, oh, my pin's not wanting to work because I got to turn it on. It's kind of like a negative 5x minus 3x, kind of the same idea here. Because this is negative 5 root 3 minus 3 root 3, which is just negative 8 root 3. And that is the final answer. You can subtract when they have the same exponents, same radical sign, and then the same number under the radical. Same goes with add over here. We've got negative 3 root 5 plus 2 root 5. So we're just going to add this negative 3 plus this positive 2. We do get negative 1, which is best written as just a negative sign. So it's negative root 5. Having a negative 1 out in front doesn't really look that great and isn't really that simplified. So, okay, so looking down here at these, root 98. And then 2 root 32. These we cannot subtract right now because if you look at these, we've got a root 32 and a root 98. Those are not the same under the radical sign. So we first have to simplify. So we're going to break down root 98. Root 98 has a perfect square that divides into it. It is one that's difficult. You can use your chart to look it up. It is root 49 times root 2, which is 7 root 2. Remember when you square root 49, it comes out as a 7, not a root 7, but a 7. Then you guys likely are looking for something that has a root 2 in it so that when you can subtract them. So if you do 32 divided by 2, you'll see that it's 16, which is a perfect square, and it goes into 32. That is one way that I do this is because I'm kind of looking to have this root 2 here so that I can subtract and they'll have the same number under the radical. Square root of 16 becomes 4, but we do have this little 2 out in front, so we do need to take 2 times 4, which is 8 root 2. And then we do 7 root 2 minus 8 root 2, which is negative 1 root 2, but we're just going to write it as negative root 2. Then if we look over at number 4, again, we have a root 8 and a root 50. We cannot add those and make root 58. That is not something you can do. You have to break these down. So root 8 can break down to root 4, root 2. I know that automatically because root 4 is a perfect square, and it's one that we use often. And 8 is not divisible by that many things, so I don't need to look at a chart for that. Root 4 becomes 2, and then that 4 times 2 becomes 8. So you get an 8 root 2. And again, it would be great if we had a root 2 at the end of the other number, the 3 root 50. So if you do 50 divided by 2, it is 25, and 25 is a perfect square. So I'm going to break it down to root 25, root 2. Root 25 becomes just 5, and 3 times 5 becomes 15, root 2. And we add those together and we get 23 root 2. Final answer. Okay, moving down, the last 4 problems are either cube roots or they are fourth roots, which does make them a little bit harder. So looking at these, the first one, number 5, you cannot change cube root 3. There's nothing that you can pull out of that, so I'm just going to leave that as it is. Knowing that we'd like to have a cube root 3, I could try 81 divided by 3 and see what number that is, and that is 27. And 27 is a perfect cube root. That's a little 3 out there. I can't quite get it there. And then 27 times 3 gives you 81. So the cube root of 27 is 3. And if you take 3 times that 2, it'll be a -6 or just a -6. And then cube root 3. And then this one's just going to come down. And when you subtract, you get -8 cube root 3. All right, moving on, looking at -48. That's a tough one for a cube root. And this one is kind of tough because there's a lot going on with it. You got to break down the -48 and the 162. So the -48, it's going to break down to a cube root -8. And I'm going to put a little negative sign in there if you can see it. Might have to rewrite that. Cube root -8, cube root 6, and then there's a 6 on the outside. So cube root -8 is -2. And 6 times -2 is -12. And then we have cube root 6. I always forget to put my little 3 up there. Then knowing that I want a cube root 6, I might take 162 divided by 6 just because I'm unsure what cube root that's going to be. I do believe that ends up being a cube root 27 and a cube root 6. Cube root 27 is 3. So you get 3 times 3, which is 9, cube root 6. And now that they are exactly the same under the radical, we can add them. And that will be -3 cube root 6. Okay, these are fourth roots, a little bit harder. So looking at this one, fourth root 5 is already there, and you can't break that down, that second one. So fourth root 405, I would like to have a 5. So if you do 405 divided by 5, it is 81, and 81 is a perfect fourth root. So it breaks down to the fourth root of 5 and the fourth root of 81. And the fourth root of 81 is 3. So you get 3 fourth root 5 plus 4 fourth root 5. That's 1 fourth root 5 basically. So this ends up being 4 fourth root 5. Lots of 4s. All right, number 8, I have root 80. This one cannot break down. So knowing that I want a fourth root 5, I'm going to go ahead and see what 80 divided by 5 is, and that is 16. So I'm going to do fourth root 16, fourth root 5, because that multiplies to be 80. And the fourth root of 16 is 2, and I'm going to take that times that 3 to get 6, fourth root 5, and then -3, fourth root 5, and it is subtraction, so it's going to be -9, fourth root 5. Okay, that takes care of addition and subtraction. I know that was fast. You can slow down the video, stop it, rewind it, whatever you need to do. So I'm going to go back up here or further down, and we're going to do multiplication. Looking at the directions, it says multiply the coefficients, multiply the radicals, simplify if necessary. I'm actually going to start with number 10 because it doesn't have any coefficients, doesn't have any leading numbers. So I'm going to do cube root 3 times cube root 9, which is just you multiply what's under the radical. Ooh, that looks bad, sorry. And that's going to be cube root 27. And the cube root of 27 is just 3. It comes out perfect. So that one's kind of nice. Looking at number 9, you're going to take the coefficients times each other. So you're going to take 3 times -4 and get -12. And then you're going to take 15 times the 45 and get, I believe it's 675. And that does break down. And I knew 25 went into that, but I thought something larger would go into it. So I looked at my sheet and I believe 225 went into it times 3 is 675. And 225 breaks down to 15. So I took the 15 times 12, which is negative 180 root 3. And that is your final answer on that one. So multiply and then break it down if possible. So that's kind of the name of the game here. 11 and 12 are very similar. You do have to use distributive property. So I'm going to distribute root 5 to root 3, and that's root 15. And distribute root 5 to 5, which just makes it 5 root 5. Now, you cannot do anything else from here. This is actually the final answer. Because root 15, yes, it would break down to root 5, root 3, but there's no reason to do that. You can't add that to anything because it's a root 3, not just a 3. So this actually just stays the way it is because you cannot pull out a perfect square root. So we leave it like it is. This one we're going to distribute 2. So we do 3 times 2, not square root of 2 times 2, but 3 times 2 because those are the regular numbers. So it's 6 square root 2. And then we do 3 square root 2 times 5 square root 2. Well, 3 times 5 will give you 15. And then square root 2 times square root 2 will give you square root 4. Square root of 4 becomes 2. And then you have 15 times 2, which is 30. And then that 6 square root 2 stays out in front. And there's nothing you can do from here. You cannot add the 30 to the 6 and make it 36 because they're not the same. It's kind of like a 6x and like a 15. You can't add those. All right, 13 and 14 are very similar. They are a radical being raised to the second power. So you basically take 3 root 5 times itself. 3 root 5 times 3 root 5. So 3 times 3 is going to give you 9. And then root 5 times root 5 will give you root 25. Root 25 breaks down to 5. And 9 times 5 is 45. Negative 4 root 10 times negative 4 root 10. You take the coefficients times each other, which is 16. And root 10 times root 10, which is root 100. Root 100 just becomes 10. So you take 16 times 10 and you get 160. Um, 15. We are going to do, it's actually distributive or FOIL. So you got to take the first term times the first term, which root 2 times root 2 is root 4. And then the first term times the last term, which is root 2 times root 3, which is positive root 6. Then you're going to take the second term times the first term, which is negative root 5 times root 2, which is a minus root 10. And then we're going to have a negative root 5 times root 3, which is a minus root 15. The only one of those square roots that breaks down is the first one, and it was going to be 2. So I get 2 plus root 6 minus root 10 minus root 15. And there's nothing more I can do from there. Last problem. I'm going to take 2 minus root 8 times 2 minus root 8. So it's like the one before where we distribute. So I'm going to take 2 times 2, which is 4. And then 2 times negative square root of 8, which is just 2, negative 2 times square root of 8. There's nothing really, it's just that number out in front. And then I'm going to take negative 8 times square root of 2, which is another negative 2 times square root of 8. And then negative square root of 8 times negative square root of 8, which is a positive square root of 64. The two middle terms can be combined, and then the last term can become 8. So it's going to be 4 minus 4 root 8 plus 8 And then the 4 plus 8 will make 12. So it'll be 12 minus 4 root 8. So that one works out that way. Okay, so I think hopefully that should help you guys. That is the end of the video. So we are going to call that good. If you have any questions, make sure